Hi everybody, welcome to this video where we're going to be talking about quantity discounts and the EOQ problem. In the last few videos we talked about various versions of the EOQ problem, including single product and multiple product EOQ problems. And in this is another version of the EOQ problem. In this case, we are going to be talking about the idea of quantity discounts. So quantity discounts are some things that suppliers give to retailers or distributors, where they let the retailer or distributor order larger quantities for smaller prices, right? Now, there are two types of quantity discounts that you see very often. You have lot-based quantity discounts and volume-based quantity discounts. In lot-based quantity discounts are based on the quantity ordered in a single lot. And volume-based quantity discount is based on the total quantity purchased over a period of time, right? So this is discount. So every time you place an order, if you remember the EOQ problem, every time you place an order, you order for the same amount. So if you have a lot-based quantity discount, then the amount that you order should be large enough that you're able to exploit the discount that you get by ordering larger quantities. Volume-based quantity discount is where the supplier says, hey, if you buy a certain quantity over the whole year, then you get a discount. Now, because we are assuming that demand is not variable, that annual demand is sort of known and fixed, volume-based quantity discount essentially tells you at what price the distributor is going to set the price for the item at. So that's basically what volume-based quantity discount boils down to, right? So for lot-based quantity discounts, there are two common schemes that are usually offered. One is all unit quantity discounts. The other is multi-unit quantity discounts or multi-block tariffs, right? So what's the major difference? So in all unit quantity discounts, the idea is that you have threshold levels, and if you hit a threshold level of the amount of units that you order in a single lot, then you get discount for the whole lot, right? As opposed to marginal unit quantity discount, which is like our taxes, where for a certain number of units, you don't get any discounts. Anything more than that, you get discounted, but only for that piece, right? So that's marginal quantity discounts. So with and we will see both of those. So in this video, we'll look at all unit quantity discounts, and in further videos, we'll talk about marginal quantity discounts and other issues related to quantity discounts, right? The two big questions that two sets of questions that you would answer for quantity discounts. One is, what is the optimal purchasing decision? That is, what is the optimal order quantity, and how does that affect our lot sizes, cycle inventories, and all of that? And under what condition should supplier offer quantity discounts? So why should suppliers offer quantity discounts at all? Why does that make sense? Now, this is where the whole supply chain aspect comes in, where you're not just talking about the single company which is placing orders from its supplier, but also what's happening with the supplier itself. So we'll talk about all of that in these series of videos on quantity discount. But first, let's look at the basic quantity discount scheme, which is the all unit quantity discount. So usually you have a pricing schedule which has a set of specified breakpoints. Now, this general sort of looking at it is very, I don't know, I find it artificial, because you usually don't have many of these. You don't get like 10 or 15 of these, but let's look at it quickly. If an order is placed which is at least as large as QI, but smaller than QI plus 1, then each unit has an average cost of CI. So what does this all mean, right? So this is what the quantity discount looks like. But let's take a concrete example, and then we'll answer everything from there. So here is a simple example of a quantity discount schedule. Now, this is the same sort of quantity discount schedule that you get whether you're doing an all unit quantity discount or you're doing marginal quantity discount. Either case, this is usually how it is, how you see it. So what you're saying is that if you order between so when you place an order, if the lot size for the order is between 0 and 4,999 units, then each of those units, how many units you order, the price that you'll pay is $3. But if the number of units that you order, if the lot size is between 5,000 and 9,999, then you pay $2.96. And finally, if you order 10,000 or more, you pay $2.92, right? So that's basically what that is. Now, so there are a lot of formulas and what you need to do, but let's look at the basic idea of what we're going to do. So what are the steps involved in doing this all unit quantity discount? So what you're going to do is, for each of these different levels in the schedule that we had, where you had no discount, so $3 and $2.92 and $2.96 and $2.92, those were the three steps that you had. For each of those, we'll calculate the appropriate order quantity using the EOQ formula, 2 times D times S over H times C. You'll notice that the C is different, right? So that's the order quantity, the unit price is different for the three cases. Everything else is the same. It's just the unit price that is different. So because of that, what we'll do is we'll calculate different values of optimal order quantity, and then we will check to see in which range the optimal order quantity lies. So if the optimal order quantity is within that range, say for example, if we calculate do the formula and the order quantity is between 0, say between 5,000 and 9,999 for $2.96, then we'll keep it. If it is between 0 and 4,999 for $3, then we'll keep it, right? So the idea is which value should we keep and which value should we ignore, right? If the optimal order quantity that you calculate using this using this formula is more than the largest value in the range, then you're going to ignore it. For everything else, you're going to do something. Now, again, these steps, they might look complex, but when we actually do the calculations, you'll notice that they're actually pretty straightforward. So this data, so what we'll do is we'll actually look at Excel, and we'll do these calculations in Excel. So what like I said, in this video, I'm going to do the all unit quantity discount, but in the next video, we'll do marginal quantity discount using the same data. But first, let's look at all unit quantity discount, right? Okay, so I have our data here. So lower limit and upper. So between 0 and 4,999, its unit price is $3. Between 5,000 and 9,999, it's $2.96, and 10,000 and more, it is $2.92, right? And we have demand and the fixed cost and the percentage of holding cost, right? So we have all of those values. So first step is to calculate the value of Q star, right? So I'm not going to say Q star, which is the, I'm just going to call it the EOQ formula, right? So let's calculate everything using the EOQ formula, which is square root of 2 times D times S divided by H times C. Right? So 2 times D times H divided by H times C. That is going to give us something. Now, I am not going to, you know what, let's just round it. That's fine. Let's round it. We usually round these numbers to 0 decimal places, so let's do that. So that's our formula, H times C. Now, a few things. So because I want to copy these formulas on demand, the unit price, and the ordering cost, unit ordering cost, and the holding cost percentage, they're all fixed, whatever the value of unit price. So all of these three things, they're all going to be absolute references. So I'm going to make them all, I guess I'm going to do them one by one. I'm going to make them all absolute references. Yeah. There you go. With that, I can copy the formula down, and I will get the corresponding EOQ formulas. So 2 times D times S D and S are the same, 20% is the same. It's the unit price that changes, right? So that's the EOQ formula. Right? That's the EOQ formula. Now this is where the next step comes in. So you'll notice that with the EOQ formula, the optimal order quantity is 6,325. It says that if demand is 120,000 for the year, ordering cost is $100 per order. Let me get rid of the decimals. Is $100 per order. And the holding cost percentage is 20%. The optimal order quantity is 6,325. Again, this is assuming that the unit price is $3, right? Now, let me just do that too. Now here, but remember that the unit price will be $3 only if the order quantity is between 0 and 4999. But because the order quantity is 6325, you're actually going to get a discount. But if you notice that, so we'll say Q star adjusted. Oops. If you notice that this number is larger than the upper limit, so if this number from the EOQ formula is larger than the upper limit, then you don't need to consider that case. That case will not be optimal at all. It is not going to be optimal. You don't have to consider that case whatsoever, right? That case is out. Now, here the optimal order quantity. So if the unit price is $2.96, the optimal order quantity is 6,367. Now that is smack dab in the middle of this range between 5,000 and 999, right? It's right within the range. If that's the case, then the value of Q star, that is the adjusted value of Q star, is the same as the original value of Q star. Because it is within the range, you can retain the number. Now, here you'll notice that this number is smaller than the lowest number in that range, right? In this case, so you're saying that for me to get for the unit price to be $2.92, I cannot order 6,411 items, because if I order 6,411 items every time I place an order, the unit price is actually going to be $2.96. So I have to order a minimum of 10,000 for me to get a unit price of $2.92. So my Q star adjusted in this case will be the lower limit. Okay. Now remember, if this number is larger than the upper limit, you don't have to consider that. That will not be an optimal case. You can completely ignore it. But if this number is within the range, you keep the number. But if this number is smaller than the lower limit, then you order a minimum of 10,000. So now here we have to compare two cases. The first case is our optimal order quantity, or EOQ, is 6,367 at a price of $2.96 versus 10,000 units every time you place an order at a unit price of $2.92. So which of these two will give us is better? Which of these two is optimal? That's what you have to figure out. To do that, we'll calculate our total cost values, right? So let's calculate holding cost, annual holding cost, annual ordering cost, and total cost, right? Let's calculate these three. Oh, material cost. See, always forget material cost. Now, in this case, material cost is, well, material to the problem, because in each of these cases, the price that you pay for each unit is different. So because of that, the material cost values are going to be different. In all the cases that we considered so far, we were able to ignore material cost for the most part. That's because the material cost for the whole year remains the same. If you assume that demand is 120,000 and the price for the item is the same number, it is fixed irrespective of when you place an order or how many units you order, and the material cost remains the same for the whole thing. So we don't have to worry about that, right? Okay. So Let's continue this quickly. Let's do the annual holding cost. So annual holding cost is Q divided by 2 times H, which has to be absolute, times C, which is $2.96, right? And this also has to be an absolute reference. No, that's that. Okay. Q over 2 times H times C. That's my annual holding cost for this case. Now my annual ordering cost for this case will be D over Q, D over Q, which gives you the number of orders in a year, times the D over Q times the cost of placing an order, which is again fixed, $100 every time you order. So these numbers, you'll notice, they are very close to each other, and they are not exactly the same because we rounded this number. And there you go. Finally, the material cost. So material cost is annual demand times the unit price. And we calculate total cost. And obviously you'll notice that the material cost, this should be an absolute reference. You'll notice that the material cost is an order of magnitude higher than this. This is only in thousands of dollars. This is in hundreds of thousands of dollars. So it's like 2 orders of magnitude higher. So given that, and that's usually the case. That's what you will see in most of these scenarios, and that's okay. So that is just the sum. Numbers. There you go. So if my lot size is 6,367, that is every time I order 6,367 items at $2.96, it's going to cost me $358, $969, $35 for the whole thing. If I order 10,000 items every time I order at $2.92, it's going to cost me $354, $520. So this is definitely cheaper than that. And so my optimal order quantity is that. Okay. So with this, I can say that my order quantity So order quantity is 10,000, right? And then we can get the usual things. Say things like what is the cycle inventory? That's half of that, right? Number of orders. Now that's easy. If you're ordering 10,000 and annual demand is 120, number of orders is easy. That is D divided by Q, right? You can order 12 times in a year, right? And then the annual or holding cost is 2920. Annual ordering cost is 1,200. Material cost is 350. Total cost is 354. I don't have to write those numbers. We already have those numbers, right? And that's it. So that is the case where you're giving quantity discounts for all the items. So in this case, as you notice, when we calculated material cost, we are saying that all the 120,000 items are bought at the unit price as long as the optimal order quantity is 10,000 or more. Now, what if you look at marginal order quantity? So that's what we're going to do next. So this is all unit discounts. Now let's talk about marginal discount. We'll do that in the next video.